We will study regression coefficients. Regression coefficient is an algebraic measurement of the slope of the regression line. This coefficient indicates that if there is a unit change in the values of one variable, then what will be the average change in the values of other variable. As there are two regression equations, so there are two regression coefficients also. The first regression coefficient will be regression coefficient of x on y, which can also be said as bxy. This coefficient represents the nature in the value of variable x for a unit change in the value of the variable y. It can be calculated on the basis of different alternative formula discussed as under. When coefficient of correlation r and both standard deviation of x and standard deviation of y are given or have been calculated. In this case, bxy will be r into standard deviation of x upon standard deviation of y. When x and y series are given and deviations are taken from actual means in both the series, bxy will be r into sigma dx dy upon sigma d square y. When x and y series are given, deviations have been taken from assumed mean either in both series or either in one or in both series. Pxy equals to sigma dx dy into n minus sigma dx into sigma dy upon sigma d square y into n minus sigma dy whole square. When in place of deviations, product moment method is used, bxy equals to sigma xy into n minus sigma x into sigma y upon sigma y square n minus sigma y whole square. Regression coefficient of y on x, byx. This coefficient represents the change in the value of variable y for a unit change in the value of variable x. Different alternative formula on the basis of calculation process are as follows. Byx will be r sigma y upon sigma x. Similarly, as it was in regression coefficient of x on y, this will be same, बस x की जगह y और y की जगह x आ जाएगा. byx equals to sigma dx dy upon sigma d square x. C byx equals to sigma dx dy into n minus sigma dx into sigma dy upon sigma d square x into n minus sigma dx whole square. D byx equals to sigma xy into n minus sigma x into sigma y upon sigma x square into n minus sigma x whole square. Properties of regression coefficients. The regression coefficients possess some important properties which are as follows. Same sign. Both the regression coefficients will have the same algebraic sign, that is, either both of these will be positive or negative. It is never possible that one of the regression coefficients is negative and the other is positive. Value of coefficients. Both the regression coefficients cannot be greater than 1. It means if one of the regression coefficients is greater than 1, the other must definitely be less than 1, because the multiplication of two regression coefficients cannot be more than 1. In other words, bxy into byx is always equal or greater than 1. 3. Calculation of correlation coefficient. If both regression coefficients are known, then correlation coefficients can be calculated by using the following formula. R equals to plus minus under root bxy into byx. It indicates that correlation coefficient is the geometric mean of two regression coefficients. Sign of correlation coefficients. The coefficient of correlation will have the same sign as that of regression coefficients. It means if regression coefficients have a negative sign, then the correlation coefficient will also be negative. And if regression coefficients have a positive sign, then R will also be positive. Mean and coefficient of correlation. Arithmetic mean of both regression coefficients will be equal to or greater than the coefficient of correlation. Symbolically, bxy plus byx upon 2 will be equal to or greater than r. Regression coefficients are independent of change of origin but not of scale. Now let us study this regression coefficient of x on y and regression coefficient of y on x with the help of an example. Calculate regression coefficients from the following data. X is given as 1, 2, 3, 4, 5, y 1, 4, 9, 16, 25. Calculation of regression coefficients. We will make the column x 1, 2, 3, 4, 5 dx from 3. 3 is assumed to be assumed mean from x, which is the center value of x. 3 comes in center, so it will be assumed, it is assumed as assumed mean. So the deviations from 3 will be noted as in a separate, it will be noted in a separate column, which is named as dx from 3. Minus 2, minus 1, 0, 1, 2. Similarly, now we will write a special column which is the square of deviations from 3. The square of deviations from 3 is d square x. 4, 1, 0, 1, 4. For y, we will write the values of y in first column. In the second column of y, we will write deviations from 11. We will write 11 because 11 is the mean which is being calculated by adding all the values of y divided upon the number of frequencies. Here the number of frequencies is 5, since we have 5 values 1, 4, 9, 16, 25. There are 5 values, so we will add 1 plus 4 plus 9 plus 16 plus 25, and what will be the total dividing what will be the total we will get dividing by by 11. Dividing by 5 we will get 11, and from the deviation from 11 dy from 11 we will get minus 10, minus 7, minus 2, 5, 14. D square y. D square y will be calculated by squaring the deviations from 11. We will get 100, 49, 4, 25. 14 into 14 will be 196. So 196 dx dy. Dx dy will be calculated by multiplying dx from 3 into dy from 11, which will be the deviations from 3 of deviations of x from 3 and deviations of y from 11. So the multiple of both will be 27, 0, 5, 28. Now we will calculate the summation, the total of the four, total of the four, sorry, total of the 5 columns. Dx from 3, we will calculate the total, we will get 0. Deviations, we should always remember that deviations will always be 0. Deviations from x from 3, deviations of y from 11 is 0. So the deviations will always be 0. So the values which will we get will be 10. By calculating the total of d square x, we will get d74 by calculating the total of d square y, and we will get 60 by calculating the total of dx dy. Now we will calculate bxy. For bxy, regression coefficient of x on y, bxy will be calculated by sigma dx dy upon sigma d square y. So dx dy is 60 and d square y is 374. So 60 upon 374 equals to 0.16. Regression coefficient of y on x, byx, will be calculated by sigma dx dy upon sigma d square x. 60 by 10 we will get 6. If the regression coefficients are 0.84 and 0.45, what would be the value of coefficient of correlation? If the two regression coefficients are minus 0.8 and minus 0.2, what would be the value of r? Calculate two regression coefficients from the following information. Standard deviation of x equals to 14, standard deviation of y equals to 20. Coefficient correlation of xy equals to 0.8. Mathematically prove that r equals to under root byx into bxy. R will be equal to bxy into byx, which will be 0.84 into 0.45, which is given in the question, the regression coefficients of x on y and y on x. So the calculated value will be under root 0.378, for which the value of the, by taking out the root of 0.378, we will get positive 0.6148. Now calculating the two regression coefficients of which are given minus zero point 0.8 and minus zero point 0.2, we have to calculate the value of r, which is the correlation coefficient. For calculating r, the formula will remain the same, and we will calculate minus zero point 0.8 into minus zero point 0.2 under root 0.16. We will get, by taking out the root of 0.16, we will get minus plus 0.04. There will not be minus, but there will be minus plus 0.04. Please correct it. It should be noted that when bxy and byx both are negative, then r will also be negative. Okay, so there will be minus 0.4, because here it is mentioned that r will be negative because both bxy and byx is negative, so there will be minus 0.4. The reason is that bxy equals to r sigma x upon sigma y. If bxy is negative, then r is negative, because sd can never be negative, which means that the reason being minus zero point 0.4, that is r being negative, is because bxy is negative. If bxy is negative, then r will also be negative, but sd, standard deviation, can never be negative. So bxy equal, now let's move on to the third question to calculate two regression coefficients. Now calculate two regression coefficients from the following informations. SD of x and SD of y is given, and regression coefficient, correlation coefficient of is given 0.8, positive 0.8. So we have to calculate two regression coefficients. Again, the formula will be same, r into sigma x upon sigma y. The values are given, we will put the values in the formula. For byx also, the formula will remain same, the process will remain same, and we will get 1.143. For the fourth question, mathematically prove that r equals to under root byx into bxy. Now bxy, we will calculate byx. Mathematically we have to calculate, prove r equals to under root byx into bxy. So for that we have to put the values of bxy and byx under equals, which is equal to r sigma x upon sigma y, byx r sigma y upon sigma x. So putting the values under root and squaring them, we will get r square. If the multiplying both the values, we will get r square, and putting an under root, putting a root, because r equals to under root bxy and byx. So putting the both the sides, putting root on both the sides, we will get r equals to under root bxy upon byx. Now the question is given, which you have to calculate on your own with the help of the sums which I have explained now. So note the question. You are given the, if you have any doubt regarding this question, please ask in the comment section below. You are try to solve it by yourself, calculate the values and give the answers in the comment section. You are given the following data again: sigma x is given, x bar is given, sigma y is given, variance of x 2.56, variance of y 2.25 is given, coefficient of correlation between x and y equals to positive 0.6 is given. Now you have to calculate two regression coefficients and two regression equations. Now the formula of regression coefficients, which you already know, and the formula of regression equations will be, note down the formula. Okay, thank you.